type npx wrangler login to use the Cloudflare CLI to log into our Cloudflare account. We'll need to install the following packages, so we're going to say yes. This will automatically open up the Cloudflare dashboard login screen where we can either sign up or log in. I've already got an account, so I'm going to log in. And now we can allow our Wrangler CLI to make changes to our Cloudflare account by clicking Allow. And now we can close this browser window, and back in our CLI, we have now successfully logged in. Type npx wrangler init to create a new Wrangler project, and I'm going to name mine Supabase at the edge. And this will step us through a few questions, and so we would like to use Git to manage this worker. We would like to create a package.json. For this example, we're not going to use TypeScript, but if you're familiar with the syntax, adding types to each lesson would be an excellent extension to the course. And we would like to create a fetch handler worker. Now we can change into that new directory and open it up in VS Code. And if we open up that worker under source and then index.js, we can get rid of these comments at the top here and see that this is exporting out an object with a function called fetch, and that's returning a new response of hello world. We can run this locally by typing npx wrangler dev, and we'll see that's now listening at localhost over port 8787. If we navigate to this URL in our browser, we'll see the text hello world. And we can change this text to anything that we would like, such as hello eggies with an egg emoji. And when we save and refresh our browser window, we'll see that new message. Head over to app.supabase.com to create a new project. If this is your first time using Supabase, you'll need to authenticate with GitHub to create an account, and now we can create a new project. I'm going to create this in my examples organization. We need to give it a name, so I'm going to call mine Supabase at the edge. We now need a database password, so I'm going to let Supabase generate a secure one for me, and then I need to make sure that I copy this as it's the only time you'll be able to read this value. And we need to select a region where our origin database is going to live. I'm going to select Sydney because it's geographically closest to my location, and now create a new project. Now this will take a few minutes to create our project, but once that's finished, we can come over to the table editor and click New Table. The name of our table is going to be Articles. And then for our columns, we have an ID column here. We're going to change the type of this to be UUID. And then if we click these three dots under default value, we want to call this UUID generate v4 function to automatically create an ID for us. We then have our created at timestamp, which defaults to whenever we create a new row. If we click this little cog, we can see extra options, and we want to untick is nullable because we should always have a created at date. And now we want to add a new column for our title, which is going to be of type text. We also don't want this one to ever be null. We want a new column for content, which will also be of type text. And again, it doesn't make sense for us to have an article without content, so we don't want that one to be nullable. And lastly, we want an is published column, which is going to be of type bool. We want the default value for this to be false. So every time we create a new article, by default, it is not yet published. And again, we want this to be not nullable. Let's click Save to create our table and those columns. Now if we come over to the SQL editor and create a new query, we can paste in this block of SQL that you can find in the description for this video, which is just inserting some new values into our articles table where we're just specifying title and content because the other columns are auto-generated. So we're just creating rows for our first, second, and third blog. And we can click Run to execute this SQL. And now if we go back to the table editor and click on our articles table, we can see our 3 articles have been inserted into our database. Type npm I for install and then at supabase/supabase-js. We can then open up our worker and import the create client function from at supabase/supabase-js. And then inside our fetch handler function here, we can create a new Supabase instance by calling create client and passing it our Supabase URL and our anon key. Now we could just declare these as plain text variables if we had RLS turned on our table. But since we don't, we want to store these values as secrets in Cloudflare. So let's head over to our Supabase dashboard and go to settings and then API and then copy our project URL from here. And then in our terminal, we can say npx wrangler secret put to declare a new secret. And this one is going to be supabase_URL. And now we can paste in the value for our secret, and that has successfully uploaded our secret to Cloudflare. Let's also grab our anon key from our Supabase dashboard and create a new secret for Supabase _anon_key and paste that value from our dashboard. We can now run npx Wrangler dev to start our development server again. And now these environment variables are automatically injected into our fetch function as this second parameter. So we can destructure Supabase _URL and Supabase anonkey. We can then pass those along to our create client function. And now we can make a request for some data from Supabase by saying await supabase.from. We then specify which table we would like to select these rows from. So in this case, articles, and then we chain on a .select to declare which columns we would like to get back. In this case, we want all of the columns, and so we're just going to use star. And we can then send these articles back as our response by replacing our hello eggies text here with our data. But this is a JSON object, and the response is expecting a string. So we just need to stringify this data object. And then we also need to send across some headers to say that the content type for this response is application/JSON. And so now if we navigate to our Cloudflare Worker, we'll see that big JSON object coming back from Supabase. And if we decided that we were ready to publish our first blog, we could update our first blog row to have is published set to true. And now if we refresh our worker, we'll see that our first blog has jumped down to the bottom, but now is published is set to true. Our worker currently gives us back all of the articles in our Supabase database, but we also want to be able to navigate to a specific article by going to its ID. And as you can see, anything going to our Cloudflare Worker is just going to load that default index.js route. Let's install the Itty router package to be able to navigate to our individual articles. Type npm I and then Itty router, and we'll also install Itty router extras. And we can run our Wrangler dev server again. And at the top of our worker, we want to import router from Itty router. We then create a new instance of a router by calling new router and declare any routes that we want to listen for. So to get all of our articles, we're going to create a get route for /articles. We then give it a function which we would like to call, which is actually just this function that we have here for fetch, only minus the fetch keyword. And we just need to remove this trailing comma at the end and also make this a proper arrow function. Now, if we scroll down to the bottom where we have our export, we just need to say that our fetch will now be handled by our router. And so now if we head back over to the browser and get rid of this ID at the end here and instead replace it with /articles, we'll see that we're displaying all of those articles from Supabase again. So if we were to copy this ID and we wanted to be able to create a route for this specific ID, we head back over to our worker and declare a new get route for /articles/:ID, which declares a dynamic route, meaning whatever the value that's after / is in the URL will be available to us as this ID parameter. We then declare our handler function for this route, where we can destructure this ID from our request.params. And now we can return a new response with our ID. And now if we navigate to our new route, we'll see its ID printed out here. So let's get that specific article from Supabase. So again, we need to create a new Supabase client by calling the create client function and passing it our Supabase URL and our Supabase anon key. And now we want to get some data from Supabase. By awaiting a call to Supabase, we want to get some records from the articles table. We want to select all of the columns, but only where there's a match for the ID column to the ID that came in from our request.params. And now we're only expecting to get a single row back from this, so we can chain on .single so that we get that actual row rather than an array with that single row in it. And now this data object is what we want to send back as our response, but rather than going through stringifying our data and setting the headers, we can use a helper function to do this for us called JSON, which comes in from our Itty router extras. We can then replace all of this response with just a call to JSON and then pass it that data object that we get back from Supabase. And we can do the same thing in our dynamic route here. Rather than creating a new response, we can just call that JSON helper and pass it our data. And now if we save this, navigate back to the browser and refresh, we'll see just the data for that specific article. Now, if the user was to try to navigate to a URL that didn't exist or an article that didn't exist, they get back null here, but we should probably handle this with a 404. So after we make that request to Supabase to get our data, we can then check if we don't actually have any data, then we want to return a status of 404 and the text not found. And this status also needs to be imported from our Itty router extras. And now if we refresh the page, we'll see a 404. Now this handles IDs that don't exist, but if our user was to navigate to some nonsense route that didn't actually exist, they would see this big scary exception from our worker. So we can declare a catch-all route at the bottom of our file by saying router.all. So this will run for any method of request, so get or post or anything else. And the route that we want to listen to is star, so basically anything that hasn't yet been handled by another route. And then we declare our handler function, which is again just going to return a status of 404 and the text not found. And now if we refresh, we'll see that proper 404 response no matter what the user navigates to. Every time a user navigates to one of our routes, we're making a request to the Supabase origin server, but each of these Cloudflare workers is running at a CDN node as close as possible to the user making that request. To reduce the number of trips to that origin server, we need to cache this value that we get back from Supabase as close to our users as possible. Type npx Wrangler KV namespace create to create a new KV store where we can cache these values. We need to give it a name, so mine's going to be articles, and once that's finished, we'll see this binding equals articles and then an ID for our KV store. So let's copy this whole object here and open up our wrangler.toml file. We then need to create a new key for KV underscore namespaces and set this equal to an array and paste that object for our new KV store. And now if we run npx Wrangler dev to start our development server, we get this error because we shouldn't use the same KV store in development mode as we are in production. So we can create a KV store specifically for running in development mode by running the same command npx Wrangler KV namespace create articles and appending --preview. And you'll see this has given us another configuration object. We actually only need the preview ID for this one, so we can copy that and then paste that into our wrangler.toml file. And now if we run our npx Wrangler dev command again, we'll see our development server is back up and running, but we've also attached this KV namespace for articles. Let's add a new route for reading from our KV store. Similarly to our environment variables, our KV stores also get automatically passed into each of our routes. And the API for reading and writing is very similar to that of local storage in the browser. So if we say articles.get, we then give it a string path. So in this case, we could say /articles, and this is asynchronous. So we need to await that promise to resolve. And then we could just return a JSON representation of our articles. And now by navigating to localhost over port 8787/read KV, we can see that we get back null because we have not yet written any articles to our KV store. So again, let's create a new route for writing to our KV store. And in here, we could create some articles, which can be an array of objects, and we'll just have a title set to test1 and another for test2. We can then await articles.put to write a value to our KV store. We give it a path, so this will be /articles, and then we need to give it a stringified version of our JSON object. And we could just return a JSON representation of our articles so we can see what we've written to the store. And now if we navigate to /write KV, we'll see the data that we've written to our KV store. And then if we navigate back to our read KV route, we'll see that we get back this stringified version of our data. So if we navigate back to our read KV route and just wrap this call to our JSON function with a JSON.parse. And now if we refresh, we'll see a JSON representation of that data. Now this stringifying and parsing is something that we're going to have to do anytime we interact with our cache. So let's create a helper utility. So in source, create a new folder called utils, and in there a file called cache.js. And then we want to populate this with two functions. So one is a read from function, which allows us to pass in a KV store and also the path that we want to read from. We'll then get that data from the KV store and return a JSON representation of it. And the opposite of that action, if we want to write to our KV store, we pass in our KV cache, the path that we would like to write to, and then also our data. We then write that to the cache at that particular path and stringify that JSON object. We can now import these helper functions in our worker by saying import read from and write to from ./utils/cache. And now if we want to get back all of our articles, we can await read from, passing in the KV store we would like to read from and also the path. And we no longer need to parse these results as we pass them to the JSON function. And let's make sure that's still working in the browser. So we want to read KV, and we're getting back that same JSON object. And so in our write KV route, let's change this to test3 and test4. And we can await a call to write to, again, passing in our KV store, our path, and the JSON version of the data we want to write. We can now get rid of this one, save our file, and go and test that it works. So let's navigate to our write KV route, and we'll see test3 and test4, and let's check that those are actually in our KV store, and we get those same values. And we can confirm that these values are not in our production cache by quitting our development server and running npx Wrangler publish. We can then copy this live published URL and paste it in the browser and append the path /read KV, and we'll see that we get back null, as we have not yet written any values to our production KV store. So the first time we navigate to this articles route, we don't have anything in our KV store, so we don't know which articles we want to send back to the user. So we have to make a request to that origin server to Supabase to go and get those. But once we've fetched these results, we could write them to the cache, and then the next user doesn't need to make an additional request all the way to the origin server. They can just read it directly from the KV store. So in our /articles route, we need to pull out our KV store that's being passed into this handler. And then once we get this data back from Supabase, we can write it to our cache. And again, that's at /articles. So we want to keep this path or key to our KV store in sync with the path for our route. That way we know this is the data that should be returned from this specific route. So now we just need to add the data that we actually want to write to the cache. And now if we save this file and head back over to the browser and refresh, you can see that we're getting those results pretty quickly from Supabase and then writing them to the cache. And if we navigate to our read-kv route, we can see that our KV store has been populated with those results. And if we refresh, it's super fast getting them from our KV store. Now, currently our Supabase database is fairly close to us geographically, so it doesn't actually take that much time to go and get these fresh results. We can simulate what this might be like for someone on the other side of the world by using this code snippet to essentially add a 3-second delay. If we then move our request to Supabase up into our set timeout, we're then going to wait for this promise to resolve, which will happen after 3 seconds. We'll pass back the data, and that's what we'll get back here, and then write to our cache and send back as a response. So exactly the same logic, but just delayed by 3 seconds. If we now save this and head back to our browser and refresh, we can see that this is taking significantly longer, actually around about 3 seconds. But if we navigate to our read KV route, we're still getting that almost instantaneously. So if we already have these results in our KV store, there's no need going off to Supabase to fetch those fresh results. We can just return them directly from the cache. So let's start by first checking whether we have cached articles. And we can do this by awaiting a read from our articles cache under the path /articles. And then if we have cached articles, then we just want to return these directly. And then if we don't have a version already cached, we can go and get them from Supabase. And we can test this is working by quitting our development server and type npx Wrangler kv:"key. And then we want to delete a particular key. We need to tell it which KV store by saying -- binding. And so this is going to be articles, all uppercase. And then the key that we want to delete is /articles. And we also need to append the preview flag. And now when we run that, it will delete our /articles key. And so now if we run npx Wrangler dev and come back over to the browser and refresh, we'll see that we need to wait that 3 seconds for that first request to go off to Supabase. But then every other time we refresh, that's coming straight back from our KV store. Let's remove that 3-second delay from our request to Supabase, and instead we can just console log. If we already have a cached value, then we can say we're sending the cache, and otherwise that we are fetching fresh articles. And we can follow a similar pattern for our dynamic route. So we need to destructure our articles KV store, and then we'll replace the body of our function. So if we already have a cached article, by reading from our articles KV store at the path for our particular ID, then we'll send back that cached article but otherwise we'll go and fetch a fresh article from Supabase. And once we get that response back, we'll go and write it to our articles KV store for this particular ID and then send it back as the response. And so now if we head back to the browser and copy one of these IDs and go to /articles/this ID, we'll see the details for that particular article. And if we have a look in the console, we fetched this article fresh from Supabase. And if we refresh a couple of times, we'll see that that's coming back very, very quickly. And if we go and have a look in the console, we're sending it from the cache. Currently, we only fetch fresh data from Supabase the first time a route is visited. Every time we refresh after that, we're getting that value from the cache. Now this is great for performance, but if one of the rows in our database changes, so for example, our second blog becomes our cool second blog, no matter how many times we refresh, we're never going to get that new title. We're always going to see the title second blog. Let's create a new route in our worker to handle revalidating pages that have become stale. So we'll say router.get, and the path for this is going to be /revalidate. Our handler function is going to have the same signature as our previous requests, where we have a request, our environment variables for Supabase URL and anon key, and our KV store for articles. And inside this handler function, we want to create a new Supabase client and then make a request for all of the articles. And then we want to await a call to write to our articles store at the path /articles with that data that we got back from Supabase. So this will overwrite that stale data in our cache with that fresh data from Supabase. We can then just return a JSON response with the key received set to true. And we can check this is working by going back to the browser and refreshing, seeing that we've still got that second blog, then navigating to our revalidate route, and then back to articles, and confirming that the title for our second blog has been updated. Our list of blogs has been revalidated, but if we navigate to a specific blog, we'll see that the title has not yet been updated. In order to revalidate a particular article, we'll need to provide our revalidate route an ID for the article that we want to fetch fresh data for. Therefore, we need to provide our route additional information in the request's body, so we need to change this from a GET request to a POST request. We also need to use the with content middleware to tell Itty router that we actually care about the body of this request, and we can import that from our Itty router extras at the top. And now in the body of our request, we can destructure the ID for our article from the request's content. And now after creating a Supabase client, we can make a request to Supabase for a particular article by awaiting supabase.from articles, where we want to select all columns where there is a match on our ID, and we just want to get back a single row. And then to make this a little less ambiguous for this second request, rather than calling this data, let's also rename this to articles. And then that's what we'll be writing to the articles cache. And so now that we have our specific article for that ID, we just need to await our write to function, updating our articles cache at the path of /articles/our articles ID with that new article that we got from Supabase. And we can no longer test this in the browser because we require a POST request, but we can send this using the Thunder client extension, which will allow us to make a POST request to localhost 8787/revalidate with our body set to a JSON object with our ID, and we can get that specific ID from the URL here and paste that in here. And now when we send this request, we'll see that our revalidate request was received. And now if we refresh the browser, we'll see our title has been updated. So currently our page is showing cached data if it's available. But if the data in the database changes, like our cool second blog becomes our very cool second blog, then the only way to update our cache and display that new title is to send a POST request to our revalidate route, passing through the ID for the article that we would like to update with fresh data from Supabase. So if we send this request and refresh the browser, we'll see our title has updated. But wouldn't it be great if we could subscribe to any changes that happen in our Supabase database and automatically call this revalidate endpoint, telling it what had changed? Well, we can do exactly that with Database Webhooks. So from the Supabase dashboard, we want to go to Database and then Database Webhooks. We then want to create a new webhook. Now you may need to click an Enable Webhooks button before you see this dialog. But now for the name of our webhook, we're going to call it revalidate_cache. We then tell it which table we would like to subscribe to changes on, so in our case articles, and which events we care about. So we want to know about inserts, updates, and deletes, as we will need to modify our cache for all of these. The type of hook is going to be HTTP request. The type of method that we want to send for our request is going to be post. We then need the URL for our hosted Revalidate endpoint, and so we can get that by publishing a new version of our Cloudflare Worker by saying npx Wrangler publish. This will print out our hosted URL here, and we just need to prepend this with https:// and then paste in our URL. And lastly, we append our revalidate path and click confirm. And now back over in our revalidate route, rather than just being passed an ID when our webhook calls our revalidate route, we're actually going to get the type, so whether this is an insert, update, or delete action, and then the new record if this is an insert or update, or the old record if this is a delete action. And so since we have this full record, we don't actually need to go and select anything from Supabase. We can just check if the type is insert or the type is update. Then we want to update the cache by calling write_to, passing it the articles cache, and then the path for our article, which will be /articles/record.id, which is the record coming in from our request. And then we also want to pass in that record as the data that we want to write to the cache. Now, if the type is delete, then we want to await a call to our cache asking it to delete the value at the path /articles/old_record.id. So this is the old record that has been deleted from our Supabase database. Now we can save this file and deploy a new version of our Cloudflare Worker by typing npx Wrangler publish, and this will print out our production URL, which we can copy from here and paste in our browser, along with our /articles endpoint. We can now see each of our 3 articles. However, if we decide it's time to actually publish our very cool second blog, we can come across to Supabase, find our very cool second blog, and toggle our isPublished column from false to true. And now if we navigate back to our Cloudflare Worker and refresh, we should see our very cool second blog is now published. And if we navigate to that particular article, we'll see that its data has also been automatically revalidated using Supabase function hooks. Currently, when Supabase calls our revalidate route, it needs to wait around while we update our caches and even make a call back to Supabase to get fresh articles before we send back this response that's just acknowledging that we received the request. Since this response doesn't rely on any of that work to have happened, we could send the acknowledgement straight away and then perform the work. Back up in our handler function for this route, we receive a third parameter called context. And context has a function called waitUntil, which we can use to continue performing work after a response is sent back from our Cloudflare Worker. Let's wrap our cache revalidation logic in a function called update cache. This is going to be an asynchronous function, and we want to move everything up until our context.waitUntil call into this function. We can then call our update cache function inside our call to the waitUntil function to perform this logic after this response has been sent back to the client. We can test this by adding a console log that we are sending response, and then add another console log at the end of our function that says updated cache. We can test this as working locally by running npx Wrangler dev and using the Thunder client extension to make a request, and we want to make a post request to localhost over port 8787/revalidate, and we can pass a JSON body with the type set to skip over any logic like the insert, update, or delete, which requires us to pass across a record or an old record. We can now send that request from Thunder client. We can see that we received that response almost immediately, and if we open up the console, we can see that we first sent back the response and then continued on to update the cache.